Alright, hi everyone. I'm just doing this video, a little bit of revision for next week's exam. So you're going to be getting two questions. Your questions could be on different topics we've covered so far in the year. So it could be, for example, transformation geometry could be one. You're going probably an orthographic projection question. There could be an ellipse question, and so on. Okay, so I'm doing a little bit of revision here on the ellipse. Just because it's a while since we did it at the start of the year. Okay, now when we're constructing our ellipse, so I have the main part drawn out. I don't have the ellipse drawn in here yet, but I just want to go through the different parts of it just so we're aware of it. Okay, now as we're aware, an ellipse is kind of like an oval shape, if you like. Okay, so it's an oval shape. It's a conic section, and it's in an oval shape. Now, there's different terms we have to be aware of on the ellipse in order to make sure that we understand everything. The first one we have to be to know is the major and minor axis and the major and minor circle. Okay. Now, major being the largest, major being something big, and minor being the smallest. So if something's minor, it's generally small. Okay. So minor being the small one, and major being the large one. Okay. Now, so in this case, I have two circles. Okay, so I have a large outer circle and I have a small inner circle. Okay, so we want to identify which is major and which is minor. Well, it's pretty obvious that the major circle, okay, is going to be the larger circle because it's the bigger one. So that means this outer circle here is going to be known as my major circle. Okay, I'll just zoom in a bit. Now, okay, so that means if that's my major circle, I now want to find my major axis. The major axis is always the diameter of my major circle. Okay, so we have two ways of looking at this now. This line here, okay, so I'm going to call this A, B. This could be my major axis, okay, and also a line coming down this direction here could be my major axis. Okay, so essentially we have an infinite number amount of major axes in here. Okay, and depending what way we orientate our major axis will determine what orientation the ellipse is going to be. Okay, so for example, if my major axis is a horizontal line, that means my ellipse is going to look something like this. Okay, if my major axis is a vertical line, that means my ellipse is going to look something like this. Okay, if my major axis was going in this line here, my ellipse would be in orientation something like this. Okay, so depending on the orientation of the major axis will determine the orientation of the ellipse. Now, so that line AB, I'm going to call this here as my major axis. Okay, we want our ellipse to go in this direction. Now, so the next thing is we need to identify the minor circle. Okay, so once we have the major circle, we know major is big. The minor circle, okay, the minor is the small one. Okay, so this circle in here is going to be the minor circle. Okay. Now, so the minor axis is the diameter of that circle. Now, an important thing to note. I'm just going to put this. Okay. Now, the important thing to note in the ellipse is that the minor axis, okay, and the major axis. So we've said that this was the major axis. Okay, so the minor axis and the major axis are always perpendicular to each other. Okay, so what perpendicular means is they're at 90 degrees to each other. There's a 90-degree angle between them. So if this is a horizontal line coming across here, okay, that means that if this is a horizontal major axis, that means my minor axis has to be perpendicular to that major axis. So it has to be at 90 degrees to that major axis, and it's going to pass through the very center of that line, okay, or the center of the major minor circles are this. So this point here, okay, so that's the center point of all my circles and the center of my major axis. That means that my minor axis is going to now be perpendicular to this along here. The length of my minor axis is the same diameter as my minor circle. Okay, so I'm going to call this CD. Okay, so that line there is my minor axis. Okay, so that's the main parts, the main terminology with the different the different lines and different circles and stuff. Now, in order to actually construct the ellipse, what we have to do, and I'm sure you're all well aware, we divide our circle up into a number of parts. Okay, so generally into 12 parts, and we use our 30 and 60 degree set square. Okay, so I'm going to go around with 30 to 60 degree set square, and I'm going to draw all these lines in. And I'm going to have a number of different parts or numbers. Okay, so this is 1, 2, 3, 4, 5, 6, 7. Okay, I'm back to 1. Okay, so I have 12 different equal sections. Okay, each of them I did using the 30-60 degree set square. Okay, like that. Now, in order to find the major axis or the different points on it, I have to draw a series of lines from where these lines intersect both my major and minor circle. Okay, so I'm going to take this line here for an example. Okay, I drew this out from the center point. It was at 30 degrees. Okay, so 30 degrees from the center point. I drew it out until it intersected my major circle. Okay, so I got this point here. Now, I drew two lines out. How do I know what lines I have to draw here? Okay, well, I'm simply drawing a line that's parallel. Okay, so this line here is coming from the major axis, or from the minor circle, sorry, from where that line intersects the minor circle, and it's parallel to the major axis. Okay, so we see that, so these two lines are parallel. Similar, this line here is parallel to the minor axis. Okay, so they're parallel. Where the two of them intersect, that gets me that point there, and that's 1 point on my curve. Okay, I'm going to do the same. I'm going to repeat the process now for this bottom one here to show you. Okay, so I'm going to take this bottom line here. Okay, I'm coming out 30 degree angle. I'm going to have to get this to where it intersects here. Now, I need to draw a line coming up from here. Okay, and it's parallel to this line. Alright, I'll come down again and draw coming out from where that line intersects the minor circle. Okay, and where the two of them intersect, that's getting me that point there. Okay, now I have the rest of these, I already have these drawn in, so as you can see right around, if you see lightly, I have them drawn in already. Okay, so after that then it's just a matter of joining up the points. Okay, so here, okay, and both the ends of the minor and major axes are always points on the curve. Okay, now so they're all my different points. Simply then just going to use freehand sketching and try keep it as one continuous line. Okay, and draw in the ellipse. Like that. Okay, and that's our elliptical curve completed. Okay, and we see that all these are perpendicular to each other. Okay, now what else do we need to know? Okay, so there's one more thing that was very important with the ellipse. Okay, and that is what's known as the focal points. Okay, so the focal points are 2 points on the ellipse that are very important and are used to find a lot of things. Okay, now to find the focal points of any ellipse, what we need to do is we need to get half of the major axis. Okay, so I'm taking half of the major axis. I'm putting it on the end of either of the minor axis. Okay, so here, and I'm swinging an arc. Okay, where that arc crosses the major axis, that's giving me one focal point. And we see it doesn't matter what end I do it on. Okay, that gives me that point, and that's going to be known as my focal points. I'm just going to call that F1. Okay, so that's that one that side, as you do on the other side, you do the exact same thing. Okay, so that's F2. Now, so they're just getting 2 focal points. So to get the focal points, we're getting the so the distance from the top or bottom of the minor axis to the focal point is equal to half of the major axis. Okay, so we need to know all that in order to solve any of the questions. Okay, so I'm going to pause this video now and I'm going to go ahead to another question and show you how to use these in a practical question. Okay, now so we have the ellipse completed or revision. I want to look at the parabola now. Okay, so the parabola is another conic section, and it's basically a curve that looks something like this. Okay, so it can look like that, or it could also maybe look something like that there. Okay, so generally something like that. Okay, now just gonna move that. Okay, now so when you're given the parabola, generally what we're given is the overall height and the overall width. Okay, and we're also told the vertex. Okay, the vertex is the very top point of the parabola. Okay, and where the vertex is will determine whether my parabola is going to look in this direction or in this direction. Okay, so it's halfway along. It's basically halfway between the box like this, and you're generally told where the vertex is. Okay, so this is the vertex here. I'm going to call this point V. Okay, now so this parabola we're constructing, it's going to be width 90 millimeters. Okay, and the height it's going to be 120. Okay, now so the first thing we need to do is need to split this in half. Okay, so from the vertex you have to draw a line that's going to be parallel to the edge of the box. Okay, so we're drawing a line down like this. Okay, so that line there is parallel with that. Okay, and what that means is if that vertex line, if this is coming down, that's going to be the center of the parabola. So that means it's going to look like this. If that vertex was running in this direction, say, okay, that means the parabola will be going like that. Now, so in order to divide up to construct the parabola, we need to divide these sides into a number of parts. Okay, so if I divide this side here into a number of parts, I have to divide the bottom into the same number of parts. The general rule of thumb is we take 1/2 and divide that into the same parts as this, and this will make sense now in a second. So to divide a line, I'm going to call this okay, I'm just going to label these A, B, C, D just for the purpose of this video. So I want to divide this line AB into a number of parts. It doesn't necessarily matter how many parts I divide up into it. The more I have, the more accurate it's going to be. Okay, so if I want to divide it up, I'm going to draw a line out at any angle. Okay, so the angle of this line doesn't make a difference, the length of it doesn't make a difference, because I want to divide this line AB up. I also could have drawn that line from B if I wanted to, and it's the same thing. Now, I'm going to divide up into 4 parts. Okay, so if I divide up into 4 parts, I'm getting the compass, and from where I drew the line, I'm going to mark off 4 equal distances. Okay, that's the key word there is equal. I take a distance on my compass and it stays the same. So that's going to be 1, 2, 3, and 4. Okay, I'll just label them 1, 2, 3, and 4. Now, so on the 4th point, because I want to divide into 4 parts, I'm going to join that line back. Okay, so I'm going to join that back to the other end of the line, like that. And I want to use now, so I want to use my sliding set squares in order to draw parallel lines to this from each of the points. So from point 4, I'm going to get it and get my other set square, line it up, and I'm going to draw lines parallel okay, from each point until they reach that line. So now I have 1, 2, 3 and 4 equal parts. Okay, now so if I divide this up into 4 equal parts, I need to divide this middle section here, okay, so I'll call this ABC, I'll call this E. Okay, I need to join A, E also into 4 equal parts. Okay, so I'm going to do the exact same thing. From A, I'm going to draw out a line. Okay, it doesn't matter the angle of the line. I want to set my compass 4 equal, so I'm going to go 1, 2, 3 and 4. Okay, I'm joining dividing the line AE, so here's A and E. I'm going to join that up. Slide the set squares. And that's that section done. Okay, so now I've that into 1, 2, 3, 4. So this half of the circle, so this half of the box, okay, I have this divided into 4 and this equal to 4. Okay, I picked 4, you could have picked 3, you could have picked 5 sides, it doesn't make a difference. Now, so I need to do the exact same thing over the far side. I can go ahead and I can repeat that process, or because it's a box, I can just simply transfer my lines across. Okay, so I know because AB is the same as CD, if I just bring that across, okay, mark it off. Okay, and them 3 points there have to be the same as this. In order to get these ones, okay, we can similarly, you can divide that up into number of parts, or you can just use your compass. Okay, take that length there, rotate it around and mark it off. Okay, and do the same thing down with the rest. So take that distance here, mark it off, take that distance there, and mark it off. Okay, now, so now I have both sides divided up in equal parts. Okay, so I have 1, 2, 3, 4, I have 1, 2, 3, 4, I have 1, 2, 3, 4, and I have 1, 2, 3, and 4. So I need to construct the parabola now. Okay, so this is this tricky part. Okay, so this line here I drew for my vertex. Okay, so V for vertex. I'll just write in vertex. I want to draw that line there. From each of these points I divided in the bottom, I want to draw lines parallel to them. Okay, so I want to draw a line parallel from each of these points to that line from the vertex, like this. Okay, so from here as well. Like that. Okay, so now I divide this up into equal bits. Now what I need to do is, from these sides lines on the side, I need to join each of these to the vertex. Now it's very important to make sure that you join it from where we divided the line up. Okay, so from this point here, here, and here. Okay, where people get sometimes confused is they join the lines from this point here. Okay, but it's actually from the line where we divided up. So I'm going to join from here, here, and here. Okay, and I'll do the same on the far side for the front. Like this. Now, okay, I'll just label these so that's 1, 2, 3, 4. So this is also going to be, so starting from A, so I went that way, that's 1, 2, 3, 4. So I'm going to go this way, 1, 2, 3, 1, 2, 3. Okay, and E is the same. So now, okay. So where the first line here intersects the first line I drew from here, that's giving me 1 point. Where the second line intersects the second line here, it's giving me another. And where the third line intersects the third line. That's giving me another vertex. Okay, so repeat that process, and we're getting all these points here. Okay, similar to the ellipse, then it's going to be a freehand curve. Okay, so we're always starting down the bottom at this here, and we're working our way up. So we're going to join all these lines. And we're going left with our parabola like this. Okay, it's the exact same principle then, constructing that parabola, and if it's going in the opposite direction. Okay, so no matter what direction it is, it's the exact same principle. It's just your lines be running in different directions.